Big game tonight, right? Yes, Cowboys are obviously on. I make sure you don't have headphones in. Hey. Okay. So, welcome back. We're gonna do some short notes today after this warm up. Don't forget, it's Stone Shape December. We're gonna have a quiz tomorrow. Tomorrow. Okay. All right. So the quiz tomorrow is over proportionality, similar triangle shortcuts, and then what we go over today, right? So on this warm up, this is kind of what this was a problem on your assignment yesterday and the day before that some people struggled on. So I want you to notice something. Do y'all see that there are two triangles here? There's a big WVU triangle, and then there's a smaller PQU triangle. Do you see how they're on top of each other? Yes. So when they're on top of each other, they're going to share this angle U that they both are kind of overlapping each other on. Okay. So both triangles share angle U, so I put an arc there. Sound good? Okay. Now the question is, what do we do next? So check this out. I see sides and I see sides. So this looks like it could be side angle side, but there's a big if they're proportional sides, like we've been doing the last 2 days. So here's what we're gonna do. We need to figure out this small side length right here. If the whole thing is 24 and this little piece is 12, how do I find this piece right here? 24, the whole thing, take away 12, gives me 12. This little piece is 12. Similarly, right here, the whole thing is 16. This little piece is 8. 16 minus 8. So this is also 8. Okay? So here's what you're going to do. You see the congruent angle that they both share. You see the small side is 12. The big side is 24. This and this, 12 and 24, are corresponding sides. 8 and 16 are corresponding sides. Okay? Now, let's make those into fractions. 12 over 24, 8 over 16. What do these fractions equal? 12 over 24. If you type it into Desmos, you'll get 0.5. You can turn it back into a fraction. It's 1/2. 8 over 16, reduce it. It's also 1/2. So are these sides proportional? Yes, they're the same fraction. Okay, small to big, same fractions. So are they similar? Yes. What was the shortcut we know? Proportional side, congruent angle, proportional side is SAS, similarity. SAS, side angle side, similarity. Two proportional side pairs and one included congruent angle. Now, if they're similar, then don't forget order matters. So U to V to W on the big one is going to match what on the small one? U to V to W in a smaller way is U to Q to P. Triangle U, Q, P. Bro. U, Q, P. Okay. I'm going to pass out these notes, or maybe you picked them up on the way in, either way, but I'm going to pass out these notes. Similar triangles is what it says. We're going to knock this out real quick. You got 2 minutes to write this down real quick. We're going to do these notes. Ready? If you don't have this down, you'll have to get it later off somebody else or maybe from the Google Classroom. Okay. But let's get going on these notes. Okay. Okay. Sorry if you didn't get this all. Here we go. Not this. Not this. Not this. There we go. All right, cool. Similar triangles. Okay. So first things first on here. Triangles are similar when they have the same shape. So it's going to look similar, no pun intended, okay? Same shape, but the thing that's different about similar is not the same size. It's a different size. Okay, never write it down. Make sure you're awake. Make sure you're writing it down. Get it? So, same shape, different size. Triangles are similar when their corresponding angles are congruent. We've said this before, say it again. The angles are going to match, they're going to be congruent, but the corresponding sides are proportional. Okay? The ratio of corresponding sides is called the, and this is our important word of the day, scale factor. We got to find a scale factor today, okay, to be successful. All right. Now, for scale factor, here's a little trick, okay? For scale factor, it's N over O. The new over the old or the original. So if you want to know scale factor, you got to know N over O. That way you know what the answer is, right? Yes. So N over O. N-O spells no. N over O is scale factor. Why am I telling you this? Because it says, what is the scale factor of ABC to DEF? You always go from the original to the new. From the old to the new, right? You always start at the original, and you end up at the new. Okay. Now, just like we've done in the last couple of days, you need to connect your corresponding sides. Does everyone see 8 connects with 12? 8 connects with 12. Those are corresponding sides. 10 connects with 15. 14 connects with 21. I'm literally drawing these lines so I can see what is corresponding. Okay. So we're not telling if they're similar. We know they're similar. But since we know they're similar, we need to write the scale factor. So check it out. It's pretty easy. All you got to do is take one of these connections and make a fraction. But the hard part is making sure you don't have it upside down. How do I know which number goes on top and which one goes on bottom? N over O. New over old. Okay? So remember right here, if you go from ABC to DEF, that means DEF is my new one. My new. This little one is my old one. So all I need to do is take one connection and write that fraction as new over old. So let's do 8 and 12. Which one's the new one, 8 or 12? 12 over, and corresponds to what? 8. So 12 corresponds to 8. All I got to do is put 12 over 8. Hit that circle for the fraction. It's 3 over 2. Okay? So this equals 3 over 2 when you reduce it. So my scale factor is 3 over 2. That's it. You're literally just finding what matches what, make it a fraction. But here's the problem. Some people are going to put 2 over 3 because they got it upside down because they didn't do new over old. So how do you know the answer? New over old, right? Okay, so similarity statements. Y'all ready? A valid similarity statement must match corresponding angles and sides. Okay, go ahead and write this. Order matters. Write a similarity statement for the triangles above. Okay, so Chihuahua. Let's take the one on the left. We'll call it ABC, right? I mean, whatever. Triangle ABC. And if it's similar, I'm going to use the squiggle. ABC is similar to triangle what? So the arc's got to match. One arc to one arc is D. Two arc to two arc is E. Three arc to three arc is F. But I want to warn you, it's not always in perfect alphabetical order, right? In this example, it was, but be careful. It's not always alphabetical. You gotta think about it, all right? Okay, here's some examples. List all the congruent angles and write a proportion that relates to the corresponding sides. Okay, so do you see the little statement right here? JKL is similar to PMN, so the first letter matches the first letter. Angle J is going to be congruent to angle P. Order matters, so let's put one arc on J, one arc on P. It's been rotated, right? Rotation. K is the middle letter. M is the middle letter. So we'll put two arcs on that, two arcs on that, angle M. Third letter L, third letter N. So the last angles are the same. Angle N. Angle L is 3 arcs. Angle N is 3 arcs. Okay. Sound good? Now, it's asking us to write a proportion. Well, what we're going to do is, match up the sides. JK, 1 arc to 2 arc, matches PM. So we can say, we always go from the original, old, to the new. Okay, so this matches up with this. So we'll put PM over JK is our proportion. We don't have any numbers, but whatever the numbers are, that would be the answer. Okay, then we have what? MN matches KL. So MN over KL. And then LJ matches NP. So whenever it says proportion, you got to be having, you have to have fractions like this, okay? Usually it's values and numbers, but in this case, it's just the names of them. If you got that, please flip it over. Let's talk about the back real quick. Show you some examples, and then I'll let you do the assignment, okay? So you understand the assignment. All right. Does anyone still need this? Okay. One more minute. And flip it over. By the way, it is Thursday, so we get out of here a little earlier than normal. All right, yep, a little less than 30 minutes. Here we go. Number 2, you don't even have to look at this picture. If you see that statement, you can match things up. First letter X matches first letter R, angle R. Second letter Y, second letter Y. Third letter Z, third letter S. You see how that works? If you have a statement, match them up. 1 to 1, 2 to 2, 3 to 3. Okay. Now this reminds me of our warm up today. Don't they have a angle that they're sharing right here that we know we can put here? Okay. We know they're similar, so that means R has to match X. S has to match Z. Okay. And again, you always go from old to new. So YR, 1 arc, 2 arc, is over 1 arc, 2 arc on the big one. YX. Okay. 2 arc, 3 arc, RS over XZ. 3 arc, 1 arc, SY over ZY. Z. So that one was like the one we just did. You're just matching up angles, looking at the statement, telling me some proportional relationships. Let's do it with some numbers on numbers 3 and 4, and then I'll be done talking, and y'all can work on Monday, Tuesday assignments and the one I'm about to give you. Okay? Does anyone still need this? I'll give you a minute. Go ahead. I would say no, because whenever you have a statement, you usually go from the original to the new. So the RYS would be the new, and it's new over old for scale factor. So, but that is the most common missed thing is getting it flipped over. Now, I don't know if other geometry teachers are being as like it's whatever, but it technically does matter, you know. Now, number 3 and 4, we good? 3. Here we go. All right, I see A matches D, B matches E, C matches F. Okay, so if I'm going from the old to the new, D, E, F. Here's my new, right? A, B, C is my old. I gotta do new over old. Just pick two sides that match. So between 1 and 2 arc is 10. Between 1 and 2 arc is 4. So I'm going to say these are corresponding. So is it 10 over 4 or 4 over 10? New over old is 4 over 10. And you can write that down, but then you want to reduce it. 4 over 10, you type it into Desmos. And then click that circle so it'll reduce the fraction to 2 over 5, my guy. See how that works? It really just depends. If you were going the other direction, it would be 5 over 2 because you're getting bigger, but this one's getting smaller. Okay? So that's how this works. New over old. What about number 4? Same idea. So the first two letters are GH, and the first two letters are JK. So let's connect GH to JK. There's a corresponding sides. We always go from the old to the new. So JKL is my new. The big one over here is my old. And again, we do new over old. 16 over 48. Was that 1/3? Yep. 1/3 is my scale factor. Okay. To go from this bigger one to this smaller one, it has to be a scale factor less than 1, and that's what it is. Cool? That's it. Yeah. So if you needed anything on the backside, here it all is for your perusal. We're going to pass out the assignment if you didn't already grab it on the way in, but if you do have it, make sure you work on that. It says assignment, okay? Similar triangles. That is different than what you got Tuesday, which says assignment, triangle similarity shortcuts. So the shortcuts was Tuesday. Today is just called similar triangles. So I'm going to pass that out if you didn't already get it, and you can work on that today, and make sure you finish the work from Monday, Tuesday. Cool.